In the last two sections of Chapter 1, we're going to be looking at functions. And in this section, 1.6, we're going to be representing those functions as rules and tables. And functions often can be used to model real-world situations, such as buying hot dogs at a food stand, which would be a relatively simple situation, but it can get more complex. So first of all, what is a function? Well, first of all, it consists of a domain, which is the set of numbers that we call inputs, and then the range, which is a set of numbers that we call the outputs, and then we have these paired up in such a way that each input matches with exactly one output. No more, no less. Exactly one output. So each input gives you exactly one output. So if we wanted to look at the idea of hot dogs, we could model this with the total cost based on the number of hot dogs you buy. So the input is how many hot dogs you buy. The output is how much it's going to cost. So here we have one hot dog will cost $1.50. Two hot dogs will cost $3. If you were to buy 5 hot dogs at that rate of $1.50 a piece, you're going to pay $7.50. And if you buy 10 hot dogs, you'll pay $15. Notice there's no quantity discount here like there would be in some situations. The domain here in this case is 1, 2, 5, and 10. So these are the input values that we used. And then the range is the output values. $1.50, $1.50, $3, $7.50, and $15. And one thing that might help you to remember domain and range, think about D comes before R in the alphabet, and input comes before output. We can represent this with a mapping diagram. So here if we look at input and output, here we have an input of 1 gives us an output of 5. Input of 2 gives us an output of 9. So does an input of 3. That's okay. You can have one output matched up with two different inputs. That's alright. This is still a function. Here we have a problem though. 1 gives us an output of 4. 2 gives us an output of 9, but also of 13. So that is not a function. Imagine if you bought 2 hot dogs. These would be expensive hot dogs, but let's say you bought 2 gourmet hot dogs, and one time they cost you $9, and then you went back the next day and they cost $13, and then a week later you went back and tried again and they were $9 again. I mean, that would be pretty ridiculous, right? And so what we want is one output for any given input. And we have a couple of rules here. So we want to relate an input to an output, and we're going to call the input variable the independent variable. So that's very often what we can choose, and then the dependent variable, in other words the output, depends on what our input is. So we want to keep straight, independent and dependent. So in our first examples we want to look at simply, is this pairing a function? And so what we're looking for is there any case of one input giving us two different outputs? So here 0 gives us 3, an input of 2 gives us an output of -1, 5 leads to 3, 9 leads to 12. This is good. There is no case of one input giving two different outputs. Now it doesn't matter. Notice we have the same output showing up twice. That's okay. So yes, this is a function. In our second example, part B though, 0 gives us an output of 4, 2 gives us an output of 6 in the first case, but then in the second case, an output of 3. That is not good. We cannot have the same input giving us different outputs. So this is not a function. In number 2, the domain of the function y equals x plus 5 is 1, 3, 7, and 10. Make a table of the function and then identify the range of the function. So the domain we can fill in as our input, 1, 3, 7, and 10. And then to get the output, we're going to take 1 plus 5. So whatever our input is, add 5. So this will give us 6. 3 plus 5, I'll go ahead and write it down here. So 3 plus 5, oops, that's a 3, will give us 8. 7 plus 5 will give us 12. And then 10 plus 5 will give us 15. And so now we can identify our range is 6, 8, 12, 12, and 15. Okay, number 3, write a rule for the function. So here we have an input of 0 gives us an output of -3. Input of 2 gives us an output of -1, etc. I'll show you a little trick here. What I like to do here is compare the change in input, so we went up by 2, to the change in output. We went up by 2. And here from 2 to 5 we went up by 3, and from -1 to 2 we're going up by 3. From 5 to 7 we're going up by 2, and from 2 to 4 we're going up by 2. So now compare the change in our input to the change in our output. So here we have an input change of 2, or increase of 2, gives us an increase of 2 in the output as well. And an increase of 3 in the input gives us an increase in 3 of the output. And an increase of 2 in the input gives us an increase of 2 in the output. And so we have this rate that we can look at. We have 2 over 2 in the case of that third change. And we had, let's see, here we had 2 over 2. And here we have 3 over 3. And notice that we get the same ratio here. 2 over 2, 3 over 3, 2 over 2, these are all equal to 1. And what that means is we're going to multiply our input times 1, and then we might have to add or subtract something. So the output equals 1 times the input, and then to figure out what we have to add or subtract. How do you get from 0 to -3? You get that by subtracting 3. And notice the same thing works here. 2 minus 3 gives us -1. 5 minus 2 gives us, 5 minus 3 gives us 2. 7 minus 3 gives us 4. So if we wanted to use variables, we could say y equals x minus 3. Shows us how to get from the input to the output. Okay, number 4. You are buying pens at $2 each to support your favorite club. Write your cost in dollars as a function of the number of pens you buy. Identify the independent and dependent variables, then identify the domain and range of the function if you have a budget of $10. Okay, so first of all, write our cost in dollars as a function of the number of pens. Well, since the pens are $2 each, our cost is going to be 2 times the number of pens that we buy. So there's the first part. Identify the independent and dependent variables. So the independent variable is P. Independent. That's what we get to choose. And so the C, cost, is dependent. The cost depends on how many pens we buy. And then identify the domain, pardon me, the domain and the range of the function if you have a budget of $10. So for the domain, how many pens can we buy? Well, we could buy 0 pens. We could decide we just don't want to buy anything today. We could buy 1 pen. We could buy 2 pens or 3 pens. Notice we can't buy half a pen or 1 3/8 pens or 2.89 pens. We can only buy whole number values here. So 0, 1, 2, 3, 4. We could buy up to a maximum of 5 pens if we spend our whole $10. And then the range will be how much money do we spend. And if we buy 0 pens, then we spend $0. 1 pen would cost us $2. 2 pens would cost $4. 3 pens would cost $6, 4 pens would cost $8, and finally 5 pens, we would be spending our entire $10. Alright, so there you have it with representing functions with rules and tables. Good luck!